So if we want to talk about the error that we might have for a particular alternating series, we have to recognize a few things. So S sub n would be the partial sum that we're using as an approximation. And so S5 would mean we're going to add up the first 5 terms of our series and use that as an estimate for what our series' actual value is. S sub 10 would mean we're adding up the first 10 terms. S stands for the actual sum. Right? So our partial sum, our approximation, is going to be off by a little bit. And so we can think about the difference between our partial sum and our actual sum would be the amount of error. Now, remember what we've said about an alternating series. If it converges, then the terms are decreasing. Right? If we consider a series that we know that converges, the sum of the series from k equals 1 to infinity of negative 1 to the k plus 1 over k. We already know this converges. And if k is 1, then this ends up being 1. And when k is 2, we have negative 1/2. When k is 3, we have positive 1/3. K is 4, 1/4, 1/5, and so on. Right? There's the first 5 terms. Now, if you think about what's happening graphically, we'll say that x is our term number, or terms added, and y is our sum. If we add just the first term, then our sum would be 1. If we add the first 2 terms, that means that our sum would be 1/2. If we add the first 3 terms, then we would have, what would that be? 3/6 plus 2/6. Our sum is back to 5/6. Right? If we subtract another 4th, then we're looking somewhere here. Right? But notice how these things are getting back and forth. Right? The actual sum would be somewhere here, and we're just bouncing back and forth over the value of the actual sum. Right? But notice how we're shrinking our distance from our actual sum. Now, the most that this sum could possibly be off is 1/5. Right? That's the absolute most we could be off by based on the first 4 terms, 1/5. So the general rule is that the difference between our estimated sum and the actual sum of an alternating series has to be less than or equal to the term after the one we stopped at. If we had just added the first 3 terms and made an estimate, then the most we could possibly be off by is 1/4. We use the absolute value because we're not, it could be an underestimate, it could be an overestimate, but the point is it's at most off by 1/4 and probably less. Right? It's pretty rare that it would be equal to the next term, although it could be. But you can't be off by any more than that. Right? So the big idea here is in an alternating series, the amount of error you have with a partial sum or with an approximation is always is less than or equal to the term after you stop adding. Right? So if our series for some reason was, 2 minus 1 plus 1/2 minus 1/4 plus 1/8, if we estimated and added these first 4 terms up, the most we could possibly be off, the amount of error, is at most 1/8.